Hey everyone, this is Eli. I wanted to build a quick utility video. This is going to be a method we're going to be using a lot throughout the series, and so I wanted to dedicate, even though it's going to be a small video, it's something I want to really make sure there's understanding on, and that's going to be the concept of adding and merging meshes together. And so this is going to be terminology going forward. So when I say add, I mean literally concatenate two arrays together. And in merge, we're going to concatenate two arrays together, but we're going to be a little smarter about it and see if there's like indices or like elements in the array. We're going to avoid duplicating them. So you can think of adding as concatenating, and then merging is like in C# or Java, it would be like a hash set. So you would, as you add to it, it's actually not adding the elements if it already exists, or you can also think of it as like a dictionary. So one, we're going to be brute force about it. The other thing, we're going to be a little smarter. Some algorithms you need just to add, like you want that duplication, and we'll see cases of that later. And then most of the time we're going to be merging. So I wanted to put a little focus on this before we get into making normals for our meshes, and normals is going to come right after this. So apologize for the wait. What I've done is I've refactored a few things from our last video. I've created a build ring method. I've put it in the Mango library itself. I'm also, for reference, every video I make is going to be a separate command, so you can actually build video 1 as a command and build rings or whatever. This video is going to be called add merge, and you'll be able to run it separately or whatever. And if you want idea, or if you want tutorial on how to set up your editor to when you save, it rebuilds a model, you can look at my last video. So I can, change this to 30, and then it's going to quickly rebuild, create a new model, and look at that. So you can look at video 1 if you want to have insight on how to do that. And with that, I'm going to build the add method. So what we're going to really be doing in this video, it's going to be just building, for lack of better words, like a cake or a pyramid. You know how you have like 3-layer cakes, or like wedding cakes, where there's smaller cakes stacked on top of bigger cakes. What we want to do is take these rings and stack them up on top of each other with smaller radii. So we'll have a ring of maybe radius of 3, and then a ring of radius 2, and then a ring of radius 1, and stack them up on each other with different offsets, and that we can build our fake wedding cake just by doing that. So with that, we're going to be building the add method to achieve it. So if we go into mesh.go, you can see this what we've done last video. We're going to create a new method. And I'm not making this, for Golang developers, I'm not making this a pointer. This means I can modify state of the mesh struct. This means I can't. I'm trying to be functional about this, so I'm not going to bother modifying the original mesh. So what's going to happen is I'm going to take whatever mesh I'm looking at currently, I'm going to pass it a new mesh, and then the result of this add function is going to be an entirely new mesh without modifying the previous two. So we're going to have an add, and then it's going to take M2 or something, and it's going to return a mesh. And I'm also avoiding this being a pointer or whatnot. I don't want the opportunity for it to be null or whatever. I really hate those kinds of situations. We're just dealing with actual structs. So, you make it for your use case. If you're trying to be super cool and efficient with it, man, go for it. Might bite you in the butt, maybe not. You know your situation better than I do. So we have two different properties in our mesh. One is the vertices, and one is the triangles. So vertices were pretty much locations in 3D space, right? So we can have if you go back to our square example, so if I open up Paint, vertices, oh man, you ready for this art? We can have 4 vertices, but only 2 triangles. So that's one triangle and that's another. So we could have 4 vertices, but only 2 triangles. So vertices are just representations and or points in 3D space. And in our add method, all we're gonna really be doing is concatenating these 2 vertice arrays together. And our merge, we're gonna be smart and go, hey, there's duplicates. Let's crunch down and be smart about this. But for now, we're just gonna be concatenating these 2 arrays together. And then we can almost do the same thing with triangles. But if you remember, our try struct is actually indices to the vertices array. So for the first mesh, so this M1 and this is M2, for our M1, we're gonna say, yeah, just point to the indices in the array. For M2, we're actually just gonna have to offset everything. And this might be confusing now. It'll make sense in a second. I'll draw it out. I'm gonna write it first so you can look at it, and then I'll draw it out and show you what's going on. But because we're concatenating the vertices arrays together, M2 is going to have to be shifted by the size of the M1 vertice array. So we're going to go ahead, and luckily Golang makes this easy for us. We're going to say like new vertices or something. And it's just literally going to be append m.vertices and m2.vertices. Actually, what I should really do before I get into this, I'm gonna create a test. So I'm gonna return an empty mesh just so this will compile. And we can start on our tests. So I made the text super huge so it shows up easy on video. I should probably move myself over. But man, is this different to deal with. So we're gonna create a new function. It's gonna be called func test add. Ooh, and it needs to take that testing parameter, testing.t. There's gonna be an arrange, and then there's gonna be a act and insert. Dope. So it's really just gonna be 2 triangles together. I'm gonna just add 2 triangles together for this simple test, and we can, if it fails, that's great. That's ideal, because then we know that we're doing stuff wrong. So range M1 is going to be a new mesh. I can just say new mesh now, right? Yeah, that's cool. Let's see if I remember. I think I can just do this. Vector dot vector 3, and I can do try. And I think that's actually valid. Cool. And yeah, this is unused. M1, M2. We're gonna act, and we're gonna say new or combined mesh, or added mesh, I guess, is M1.add M2. And we're gonna know 2 things immediately about this. We're gonna say assert dot equal. We know that the added mesh dot triangles is gonna be 2. So actually I need to write. Oh wait, there's a cute little method I can do. I think it's len. Yep. All right. So what we're doing in this assertion is we're gonna say, hey, I know I'm supposed to have 2 triangles at the end of this, and then also know I'm supposed to have what do you call it? 6 vertices. So T, let's see, len, added mesh, acid meth. Yeah, that's awesome. Vertices equals to 6. So this is gonna, actually, yeah, this is gonna be super wrong, but I'm gonna actually fill this in now. So what I'm gonna make these 2 triangles to be, so this is gonna be 0, 1, 2. This is gonna be 0, 1, 2. And then we're gonna, oh, I'm dumb. Excuse me. I need to say try 0, 1, 2. There we go. I need to do the same thing. Oh, need to do the same thing with the other. But it looks like I can remove this. And that's another way to define it. And for some reason, every time I hit format, it's bringing me to the top of the page. I really need to figure out why it's doing that. I have opinions over the new Go Please usage in VS Code, but we won't get into that now. Cool, so we define triangles whose vertices, or sorry, indices of that triangle point to different vertices in the mesh. And there's no vertices now, so we need to define them. So what I'm gonna do is what we did from that first video. I'm literally just gonna be making a square. So you can think of it just looking at this one region. So this is gonna be 0, 1, 2. Remember, it has to be clockwise. And then same thing for the other one, 0, 1, 2. And so we're gonna be getting a square in the end after we merge these 2 triangles together. So if we look at our reference sheet, this awesome reference sheet, I'm gonna start at the top left corner, I'm gonna go to the top right corner, and then I'm gonna go to the bottom right corner. So we're gonna say vector 3 dot, or 0, if I could type, we'll do vector 3 up. And then to the right will be vector, let me do the up again, dot add vector, can I do right? Right? Yes. So this looks super clean, right? No. And then I'm gonna do vector dot vector 3, and then I can do just right. So if you look at this one, we're starting up, we're going upright, and then we're just going right. So if this is our 0, we're first starting here with our vector 3 up, and then we're doing vector 3 up right, and then we're doing just vector 3 right. So 1, 2, 3, that's clockwise. That's what these are referencing, and then we're good. We got our triangle for our first mesh. And then our second mesh, we're gonna do something extremely similar. Let's see. That's honestly a good enough test that would make these things pass in a real scenario, but I wanna be proper. So we're starting up again, and then we're immediately going bottom right, and then we're going to 0. So the last one here should be vector dot 0. Hell yeah, hell yeah. All right, so these tests should pass, or these tests should fail, excuse me. That was wrong of me. Awesome. 2 items, but it has 0. 6 items, but it has 0. Thank you. So we can make these tests pass pretty quickly just by concatenating arrays. and then we can go back to writing this test and make sure everything's correct in the end. And that's what we'll do. This is like proper, like, what do you call it? Like, the way it should be done, the most formal, like you write as much code as it takes to make things fail or whatever. Write as much test to make it fail, and then you write enough code to make the test pass, and then you write enough test to make it fail again, and all that. You go back and forth or whatever. That's what I'm doing. Excuse me if this is boring. I'm trying to be thorough and catch myself. This is my second one, so I'm gonna need the thoroughness. So all we're gonna do is concatenate two arrays together, or whatever. And luckily in Golang, that's super duper easy. So this mesh is gonna take new vertices and the new triangles. Blep. And then we're gonna say just new whoops. Equals append m.triangles, m2.triangles. That's so freaking cool, dude. Oh, did I redefine a method? Yeah, I think I did. Oh, and I have to make sure they're actually being initialized instead of assigned to. Sometimes it's annoying, but I wish Python had that. Awesome, awesome output. Yeah, we have our test passing and all that. Big surprise, even though that's really not doing what we need it to do. I guess I'll demonstrate that here. So I'll do something simple. I'll say, so we're making a cake or whatever. Making a cake. I'll be deliberate. How do you say that? I'll be explicit. Bottom layer equals, I have to assign bottom layer. And we're gonna make this a higher resolution, and it's gonna be a wider base, and there's gonna be no offset. And then we're gonna say middle layer, and that's going to be a little less faces, maybe 24, and the offset's going to be small, or not, the radius is going to be smaller, and the offset is actually going to be up a unit, dot up, and then we're going to go up one more layer, top. And we don't need as many faces again, so we're gonna go like 16 or something. I am eyeballing all these measurements. It's just kind of a feel thing. For sake of example, whatever, man. So I'm gonna do another up. So I'm gonna, for sake of explicitness, I'm gonna say multiply by constant 2. Now, actually, I'm gonna change all these because it's gonna make me, when I refactor this, a little bit easier. So 0, whatever. And now we need to combine all these layers. So we're gonna say bottom layer dot add middle layer dot add top layer. And that's gonna be our cake. It's gonna be our cake. So right now our add method is kind of wonky, so I expect a wonky mesh when I hit save, if it even works. Yes, perfect. Because we do actually add new vertices in our concatenation, but our triangles aren't using those new vertices. The triangles are actually using the old vertices that are referring to mesh ones. So you can think of our top layer, it has these triangles, but these triangles are accidentally referencing bottom layers triangles, or vertices, sorry. Top layers triangles are representing bottom layers vertices, and so you get this weird crap. So we have to do proper offsetting. And what sucks is, and this is another super big thing, The 3D model formats are very wild west, where you can have hundreds or thousands of vertices in your file that are just completely unused, and it's another quick, easy cleanup or whatever. But that happens. It's kind of dumb. So anyway, we're gonna fix that now. We're first gonna make our tests expect proper offset, and then we're gonna make the test pass, and then we'll see this cute cake kind of appear, or whatever, or pyramid, or whatever you want to call it. So, stated previously, our triangles our vertices can stay the same, but our triangles are gonna have to change. So we're gonna say new tries is equal to just m.tries, and now we're gonna lay on, actually, excuse me, test first. So we know to expect, it's gonna be pretty simple. We're just gonna expect these first three, and then we're gonna expect these next three. So we're gonna say assert dot equal t. Let's see, how easily can I make this for myself? I'm not sure. I'm sure there's cute things I can do. Let's see, can I do a cute thing? I think I might be able to just highlight them all, and then I can do middle click and then paste. Yeah, that's about as close enough as I'm gonna get. And then they are gonna expect the result. And the result is gonna be added mesh vertices 0 dot nothing, and 2 and 1. Honestly, all these tests should still pass. So, and this one's gonna be right, and this one's gonna be 0. So all these tests should still pass after I do this, if I'm right, which is seldom. Oh, well, yeah, this one just needs to remove that. 0, 1, 2, 3, 4, 5. This should already have been happening with the concatenation, I think. Output, please. Yes, so duh, that was already happening. What are you bothering with, Eli? What we're really worried about are these triangles. So we're gonna say assert equal t, and then we're gonna say try. It's gonna be a 0, 1, 2, and then it's gonna be 0, and this still should be passing, right? Thank you for continually switching me over. But this is where it's gonna break, right here, and then we're gonna do 3, 4, 5. Thank you again for switching me over, and failure. Hell yeah. So again, we're expecting 3, 4, 5, but our triangles pointing to its original vertices, but they've been shifted now, so now we have to shift this. Perfect. So yeah, we're just gonna do exactly that. So we have new triangles, and we're just gonna change this. And I'm gonna write this a less efficient way, where I'm gonna be continually expanding and changing the size of the array, but you could take a little extra care and just go, hey, I already know the size of the array. Let me just initialize it to begin with. Definitely encourage you to take that extra step. So we're gonna say for what are we iterating over? M2's triangles for try and range of M2 dot triangles, right? Yes. I'm gonna say new tries equals append new tries, and then we're gonna append a new triangle to it. Sure. It's gonna be try dot p1, try dot p2, and then try dot p3. But we gotta shift it over by the length of the vertices. So we're gonna say m1 vert count equals length of vertices. And I'm just gonna break this over into new lines because I think it looks better. And that's definitely subjective. And even if it looks better, it doesn't mean it actually helps me. So it's a whole nother can of worms. I hit save. Now I hit save. I'll test pass. And holy moly, if you look at it at the right angle, it doesn't really look at it like a wedding cake, maybe more like a kid's toy or something. Those rings where you... Tower of Hanoi, that's what we did. That's computer science shit. We did the Tower of Hanoi right there. Boom. And that's pretty much all you need to the add function. So it's like super duper simple, but we're going to be using it a lot. So that's cool. That was quick and easy. We can take... Man, do I feel like adding merge? I guess I'll do merge. Hey, Sober Eli here. So it's the next day. I've been cleaning up code and whatnot. And I wrote the merge code out or whatnot. It goes on for another hour accidentally. Also, you know, as I'm cleaning up, I realized that most of this code is going to change as soon as we start talking about UV mapping and normals, and the way you merge vertices changes based on the normals of those vertices. So the code I kind of wrote, it only works for what we have right now, and as soon as I introduce normals, it's all going to change. So I'm not going to bother, you know, extending out this video any longer. So if you're interested in how you can merge vertices, I will have that code published to the GitHub repo. It's not going to be in the Mango library itself. It's going to be in the command video folder for this video. So there'll be a link down in the description, and you can take a look if you're really interested. But we're going to dedicate a whole video really to merging vertices. It's going to be called Vertex Welding, and that's going to happen right after we talk on normals. The next video I'm going to do is going to be preparing us for the normals. It's going to be one more short video. It's just literally going to be extending the build ring functionality. And then we're going to jump into it. I'm really excited. Thanks for watching.